Hi students. So today we discuss the new concept, that is exponential and logarithmic function. What is that? Exponential and logarithmic function. So already if people know that what is the exponential function and what is the logarithmic function. Okay. So students, I can say some brief about exponential function. So here this is a graph of exponential function. So what is that? Long y-axis, long x-axis, this is 0. So first we can take this. So here we can draw the graph of y equal to x. Y equal to x is nothing but this is a identity function graph. So y equal to x, this is y equal to x square along parabola. This is y equal to x cube, y equal to x raised to 4, and so on. So this is a graph of y equal to 10 raised to x. So here 10 is any base, so any positive base 10 it is. Okay, so this is graph of exponential function. Is clear that? So that first what we want to do that. So this is line y is equal to x. So this is the line y equal to x. So this is starting from 0. So its point is 1, 1. So all the graphs are intersect common between the point, that is 1, 1. Okay, so here y equal to x, y equal to x square, y equal to x is the equation of line passing through the origin. So y equal to x square, parabola, y equal to x cube, that is also parabola, y equal to x raised to 4, y equal to x raised to 5, so on. So y is equal to 10 raised to x. 10 be the any positive number, that is said to be base. Okay, so here this is the graph of exponential function. Then what is the definition of exponential function? So here the exponential function with positive base b is greater than 1. What is that? The exponential function with the positive base. So the base of this function should be always positive. So that's why positive base b is greater than 1 is the function, that is y is equal to f of x, that is equal to b raised to x. So b raised to x. This is exponential function. So this b is a base. Base is always greater than 1. That is always positive quantity. Is clear that? So that means, so y equal to 10 raised to x. 10 is the any positive base. Is clear that? So that's why this is the definition of exponential function. The exponential function with the positive base. The base should be positive. Is the function, that is y equal to f of x, that is equal to b raised to x. B raised to x. Okay. So from the graph we can see that the domain of the exponential function is real number. The domain of the exponential function is always real number. That means the input number of exponential function is always a real number, and the range of the exponential function is positive real number. See that the range should be positive reason. Is clear that? So the range of the exponential function should be r plus. R plus is nothing but a positive real number. Is clear that? The graph, the point 0, 1, which is the point 0, 1, x is 0 and y is 1. The point 0, 1 is the always graph of the exponential function. Remember student, the point order pair 0, 1 is the always graph of the exponential function. Okay, so here the exponential function is ever increasing. Exponential function is ever increasing function. This is increasing function. Is clear that? And y is equal to e raised to x. Y equal to e raised to x is called natural exponential function. So y equal to e raised to x is called, what is that? Natural exponential function. Is clear that? This is all about some exponential function. Is clear that? So if you have any doubt, see your textbook. So here clarification is there. Then we'll go for logarithmic function. Logarithmic function is also, see that what is a logarithmic function. So see that friends, logarithmic function and exponential function are inverse to each other. That means opposite to each other. Here, say that this is the point 1, 0, that is nothing but the x-axis 1, y-axis 0. So this graph should be y equal to log of x to the base 10. Base is always positive. Is clear that? Y equal to log of x to the base 10. Y equal to log of x to the base e. This is natural logarithm. Log e. Log x to the base e. So this is log x to the base 2. So see that students here, the definition of logarithmic function is let b be the any positive base. B is always greater than 1. Be a real number. Then we say that logarithm of a, logarithm of point a to the base b is x. Logarithm of a to the base b is x. That is b raised to x is equal to a. Base raised to x is equal to a, or else you can write x is equal to log of a to the base b. So this base shifted to right hand side, it will become exponential function become logarithmic function. That's why exponential function and logarithmic functions are inverse to each other. Is clear that? So x is equal to log of a to the base b. So b is the base. Is clear that? So this is log function. So see that here also the domain of log function is always positive real number. The domain of log function is always positive real number. The range of log function is set of all real number. Range should be positive as well as negative. Okay. The point 1 comma 0. This point. The point 1 comma 0 is always on the graph of the logarithmic function. Always on the graph of the logarithmic function. The log function is ever increasing function. The log function is ever increasing. Okay, students. This is some basic idea about logarithmic function as well as exponential function. Okay. So in this concept, what we are to do that the derivative of exponential function as well as logarithmic function. Say there, student. What is the exponential function? Exponential function is nothing but y is equal to e raised to x. This type of functions are called exponential function. Okay, we can discuss this type of example. And y is equal to log x. Y equal to log x to the base e. This is basic natural logarithm. So we can discuss this type of examples. Okay, if you people know about anything know about exponential and logarithmic function, you see your textbook in NCERT textbook. So the detail will be there. Okay, so this is one more concept, not necessary to explain some more class. So students, if you have any doubt, you can see your textbook in NCERT textbook. The detail is there. Okay, so here these are the things you can write. Okay, write it. So students, see that. So this is the graph of y is equal to e raised to x and y is equal to log x to the base e. So here, say that this is the graph 0, 1 is always the graph of exponential function. So y equal to e raised to x is the exponential function. So the graph 0, 1 is always the graph of the exponential function. Okay, so here this is graph. This is the graph of the logarithmic function. The point 1, 0 indicate the graph of the log function. The point 0, 1 indicate the graph of the exponential function. The point 1, 0 indicate the graph of log function. Okay, here see that what is that? In this graph, here this graph gives a plot of y equal to exponential function and y equal to logarithmic function. So it is of interest to observe that two curves are mirror image of each other. So the two curves are, this is 0, this is 1, 0. So the two curves are mirror image of each other by separated by the line y is equal to x. That means the exponential function and logarithmic functions are inverse to each other. See that this is are mirror image of each other reflected in the line y is equal to x. So this reflect this is 0, 1 y equal to x. This is 1, 0 y equal to log x. So that's why I say that what is that the exponential function and the logarithmic functions are inverse to each other. Is clear that? So y is equal to e raised to x. This is said to be exponential function, and y equal to log of x to the base e. This is said to be logarithmic function, or else otherwise this can be done as simply log x. Log x is nothing but here there is a no find. Obviously this is exponential find. So log x is same as log of x to the base e, or this also same as ln of x. It is nothing but ln of x. That is also same, log x. Is clear that? So this is all about exponential and logarithmic functions, friends. Okay, and the some of the very important properties are there. The logarithmic properties are, the very important logarithmic properties are, so note down, these are very important while solving the problems. These properties are very importantly useful. Okay, so first one, log of m into n, this can be written as, here there is a no use nothing but that is exponential. Log of m into n can be written as log m plus log m. Log m plus log m. So multiplication of logarithmic term can be splitted into log of m into n can be written as log m plus log m. Okay, to the base e, that is nothing but to the base e, to the base e, naturally exponential base. Okay, and second one, log of m by n, this can be written as, the divided rule of logarithm can be written as log m minus log m. Log m to the base e, log m to the base e. So the multiplication term can be written as log of m into n is log m plus log m. The divided rule, log of m by n can be written as log m minus log m. It's very important. And third one is very important. Third one is n log m. N log m to the base e. N log m to the base e can be written as log of m raised to n to the base e. So n log m can be written as log of m raised to n. Is clear that? So log of m raised to n can be written as, by using logarithmic property, n log m. So this term shifted to power m to the power n. Is clear that? This is very important property. It's very important property. Okay, and the fourth one property is log of m to the base n. So log of m to the base e, log of n to the base e, log of m to the base e, log of n to the base e. So the base e is the natural exponential base. But here in this property, log of m to another base n is there. Here there is no exponential base. So log of m to the base n. In that type of logarithmic function, we can write as log m divided by log n. This can be written as log of m to the other base n can be written as log m divided by log n. Is clear that? So students, this is very important. Suppose more than two functions are there, not a problem. Same plus m n n, log m plus log n plus log n, so on something. Okay, divided rule is there. More than two or function, not a problem. Log m minus log n minus log n, so on. Okay, so n log m can be written as log of m raised to n. This is very important property while solving the examples. Okay, and here also log of m to the base n can be written as the change of base theorem. This is the change of base theorem can be written as log m divided by log n. Log m divided by log n. Okay, this is very important point. These are very important point. So make note of this property. Very important property. These are. Okay. Next, then we can solve the exponential function as logarithmic function. Then we need the formula for exponential function as well as logarithmic function. Okay, so that's why again write this is formula d by dx of e raised to x. Derivative of exponential function is exponential function. Okay, and second one, this is very important, d by dx of log x. D by dx of log x is 1 divided by x. These two are very important formulas while solving the 1 mark problem. This is also 1 mark concept. This is also the continued part of derivative of composition of a function. So already we solved the exercise 5.2 regarding composition or derivative of composition of function. So likewise that is also same. So derivative of, these are a very important formula. So write it is. So derivative of e raised to x is e raised to x. Derivative of log x is 1 divided by x. Okay. So these are the important points. So this is some derivative formula. Write down. These are the some important properties. Properties of logarithmic function. Okay. Write down this. Students, these are the examples regarding exponential and logarithmic function. The first one is e raised to minus x. This is the exponential function of the composition type. So sine of log x. So cos inverse of e raised to x, e raised to cos x. So these examples are basically contains exponential function as well as logarithmic function as well as composition of a function. Is clear that? So already we solved composition of the derivative of composition of function. So we can apply the same rule. Okay? So I can solve one by one. See that? The first one is, first one, let us take y is equal to e raised to minus x. Y equal to e raised to minus x. Then derivative of this function will dy by derivative. This is always, this is x implicit function in the form of, you can write in the form of y equal to f of x, but these are the explicit function because this relation we can write in the form of y equal to f of x. Is clear that? So here then the derivative of y is dy by dx is equal to, so first of all this is e raised to x form keep as it is. Then what is the derivative of e raised to x? So already we know that. What is the derivative of e raised to x? d by dx of e raised to x is e raised to x, and d by dx of the log x function can be written as 1 divided by x. These two problems can be solved by using the first principle method of the derivative. Okay, so here derivative of e raised to x is e raised to x keep as it is, but this is not x, this is minus x. Then apply composition rule. Okay, so derivative of e raised to x is, so first derivative of e raised to x is e raised to x as it is with respect to, this is composition function d by dx of minus x. Is clear that? E raised to positive x, that is not a problem. Derivative of e raised to x is e raised to x, but this is derivative e raised to x form is there, but this is minus x. So derivative of e raised to minus x is e raised to minus x. Instead of x, what is there? Minus x is there. Some differentiate again d by dx of minus x. The answer should be that is equal to e raised to minus x as it is. So derivative of minus x is minus 1. So the answer should be minus e raised to minus x. Minus e raised to minus x. Okay. This is also one important property, that is d by dx of e raised to minus x can be written as minus e raised to minus x. This is also one property. Okay. Example. One more question. Very simple. So this is successive differential. Okay. And second one. What is the second term? Let us consider. We can take y equal to sine of log x. Sine of log x. So this is composition function. So sine x. Instead of x, what is there? Log x is there. It's clear that this is a composition function. So then automatically dy by dx. First of all, keep the log x whole function as treated as a x. Is clear that? So derivative of sine x is cos x. Okay? Derivative of sine x should be cos x. What is your x? X is log x. Okay? Then instead of x, what is there? d by dx of log x. Clear that? Derivative of sine x, cos x. Instead of x, what is there? Log x. Then differentiate this function again. This is composition of derivative. Okay? Then that is equal to cos of log x keep as it is. Then derivative of log x. What is the derivative of log x? Derivative of log x is 1 divided by x. This is the answer. Is clear that? Friends, very simple example it is. And next, third one, let us consider y is equal to cos inverse of third one, let us consider y is equal to cos inverse of e raised to x. Cos inverse of e raised to x. This is also called inverse trigonometric function. So already we know that what is the derivative of inverse trigonometric function? So d by dx of cos inverse x. What is the derivative of cos inverse x? Minus 1 divided by root of 1 minus x square is the formula. So apply that one. This is the form y equal to cos inverse of, instead of x, e raised to x is there. Cos inverse of x. So first apply the derivative of cos inverse of x. Then dy by dx equal to, what is the derivative of cos inverse of x? Minus 1 divided by root of 1 minus x square. What is your x? E raised to x whole square. Is clear that? So derivative of cos inverse of x minus 1 divided by 1 minus x square. Here cos inverse of x, instead of x what is there? E raised to x. So e raised to x can be written as x. Okay, derivative of cos inverse of x is minus 1 divided by root of 1 minus, this is x whole square. With respect to x what is there? E raised to x. With respect to d by dx of e raised to x. D by dx of e raised to x. Is clear that? Minus 1 divided by root of 1 minus x square. Instead of x what is there? E raised to x. Again differentiate this function. Okay, then last answer is minus 1 divided by root of 1 minus e raised to x its whole square into what is the derivative of e raised to x? E raised to x and this. This is the answer. Is clear then? Okay, and lastly fourth one. What is the fourth one? E raised to cos x. Y equal to e raised to cos x. It's also same. Very simple example it is also. Okay, so dy by dx equal to, first we resolve the form e raised to x form. It's clear that? E raised to x it is. What is the derivative of e raised to x? E raised to x. With respect to d by dx of, instead of x what is there? Cos x. Is clear that? So that is equal to, results are e raised to cos x. What is the d by dx of cos x? Minus 1. This is that. Okay. Now this is derivative of exponential function as well as the logarithmic function by using derivative of composition of a function. Is clear that? Write on this for example. If you have any doubt, ask me. Okay. Write on first. So students, this is exercise 5.4 based on the concept that is exponential function as well as logarithmic function. Okay, so here differentiate the following function with respect to x. The first one example is e raised to x by sin x, e raised to sin inverse of x. So e raised to x cubed. So it containing exponential function as well as logarithmic function with composition of function. Composition is nothing but two or more than two function. Is clear that? So e raised to sin inverse of x, e raised to x cube, instead of x what is there? X cube is there. So here sin of tan inverse e raised to minus x. This is more than 3 function. Composition of more than 3 function. Log of cos e raised to x. So e raised to x, e raised to x square, e raised to x cube, so on e raised to x raised to 5. Root of e raised to root x. Root of e raised to root x, and 8th one log of log x, 9th one cos x by log x, 10th one cos of log x plus e raised to x. So this is also 1 mark concept. 1 mark, very important concept. You can solve one by one example. So the first one, say that, what is that? Let us take y is equal to e raised to x divided by sin x. E raised to x divided by sin x. This is of the form u divided by t. So what is the formula for u by v? D by dx of u divided by p equal to p into du by dx, p into du by dx minus u into dv by dx divided by p square is the formula. Divided by p square is the formula. Already we know that. Okay. So apply that formula you get. Okay. This is u by v form. Then what we have to find that dy by dx. Dy by dx equal to p as it is. P is nothing but sin x as it is. Then d by dx of e raised to x minus e raised to x it is. Then d by dx of sin x. D by dx of sin x whole divided by p square. Sin x is square. Okay. Denominator into derivative of numerator minus numerator into derivative of denominator whole divided by denominator whole square. Okay. Then sin x as it is. Derivative of e raised to x is e raised to x minus e raised to x as it is. So derivative of sin x is cos x whole divided by sin x its whole square is the answer. Or else you can take e raised to x as a common. E raised to x is a common. Sin x minus cos x divided by sin x whole square. Sin x whole square is nothing but you can write this as a sin square x. Sin square x. Very simple example is right now. So the next one is the second one example. Let us consider y is equal to e raised to sin inverse of x. E raised to sin inverse of x. And third one, let's consider y equal to e raised to x whole cube. E raised to x whole cube. Okay. So here in this example, you can write this is e raised to sin inverse of x form is there. Okay. First of all, keep this function as e raised to x as it is. What is the derivative of e raised to x? Derivative of e raised to x is e raised to x. Instead of x, what is there? Sin inverse of x. Then again differentiate this function. Okay. Then dy by dx is equal to derivative of e raised to x is e raised to x. X should be sin inverse of x with respect to this function d by dx of sin inverse of x. D by dx of sin inverse of x. Okay. So then that is equal to e raised to sin inverse of x as it is. Then into what is the d by dx of sin inverse of x? What is the derivative of sin inverse of x? 1 divided by root of 1 minus x square is the answer. Very simple. Okay. So this is also same example. This third one. Let us consider y equal to e raised to x cube. This is also same form. So e raised to keep this whole function as a x. Then differentiate again differentiate. Okay. So this is also very important example, friends. The third one is your work. Third one is your work. Okay. Then fourth one I can solve. Fourth one. What is that fourth one? Fourth one. Let us consider sin of tan inverse e raised to minus x. This is one function, two function, three function. More than two function is there. So composition of the function. So same apply as it is, same procedure. Then dy by dx. Then dy by dx. First it is sin x formula. The sin of whole bracket should be considered as a x. What is the derivative of sin x? Cos x. So derivative of sin x should be cos x. Cos of what is your x? Tan inverse of e raised to minus x. With respect to d by dx, what is instead of x? What is there? Tan inverse of e raised to minus x. Is clear that the derivative of sin x is cos x. Instead of x, tan inverse of e raised to minus x. So differentiate again this function. Okay, that is equal to cos of tan inverse e raised to minus x as it is. Then derivative of this is the tan inverse of x part. What is the derivative of terms of x? 1 divided by 1 plus x square. What is the derivative of tan inverse of this function should be x? Derivative of terms of x is 1 divided by 1 plus x square. What is your x? E raised to minus x whole square. Is clear that derivative of tan inverse of x is 1 divided by 1 plus x whole square. Instead of x, what is there? Then respect to d by dx of e raised to minus instead of x, e raised to x is there. Then cos of tan inverse e raised to minus x. So 1 divided by 1 plus e raised to minus x whole square. Then what is the derivative of e raised to minus x? Derivative of e raised to minus x already I solved the formula, that is derivative of e raised to x is e raised to x. Derivative of e raised to minus x is minus e raised to minus x. Derivative of e raised to minus x is minus e raised to minus x is the answer. Is clear that students? This is very easily we can solve. This is composition of a function with containing exponential function. Okay, so write down this example and the fifth one is your one. The fifth one is your same log x part is there. Derivative of log x apply, then apply cos x, then apply e raised to x. Okay, first write down this example. So sixth one is also, this is also very easy example. You can try yourself. E raised to x, e raised to x square, e raised to x cube, which is obviously e raised to x, we know that. So e raised to x square. Derivative of e raised to x square is e raised to x square with respect to x square. E raised to x cube with respect to x cube. You can write. Okay. So here the seventh example is, what is that? Let us consider y equal to root of e raised to root x. So this whole function should be treated as x. This is of the form root x. What is the derivative of root x? Then what is the derivative of root x? Dy by dx is equal to derivative of root x is 1 divided by 2 root of x. 2 root of what is your x? E raised to x. Clear that? This is derivative of y equal to root x form is there. Derivative of root x is 1 divided by 2 root of x. This is your x. Instead of x, what is there? D by dx of what is your x? E raised to root x. That is equal to again 1 divided by 2 root of e raised to root x with respect to d by dx of this of the form e raised to x form. What is the derivative of e raised to x? E raised to x as it is root x. Instead of x is there d by dx of root x. D by dx of root x. Okay, see that? This is the form root x. Derivative of root x is whole divided by x. Remember derivative of this function 1 divided by 2 root of x. Instead of x, what is there? E raised to root x. Then differentiate this function d by dx of e raised to root x. What is the derivative of e raised to x? Derivative of e raised to x is e raised to x. Instead of x, what is there? Root x. Okay. And the next step is 1 divided by 2 root of e raised to root x into e raised to root x into 1 divided by 2 root x. 1 divided by 2 root x. Is clear that? Okay. Then the last the eighth one example is, let us consider this one. Then dy by dx is equal to this is the form log x. What is the derivative of log x? Derivative of log x is 1 divided by x. Derivative of log 1 divided by x. What is log x? Derivative of log this function should be x. Derivative of log x is 1 divided by x. What is your x? Log x. Instead of what is there? D by dx of log x. Clear that? So this is log of log x. Log of x. Derivative of log x is 1 divided by x. Instead of x, what is there? Log x. Then differentiate again d by dx of log x. Okay? This should be 1 divided by log x as it is into. What is the derivative of again log x? Derivative of log x is 1 divided by x. Okay? This is very important example, friends. So you can write this example. So students, this is the last example, that is y equal to cos of log x plus e raised to x. So the ninth example is same as the first example. You people try yourself. Okay. So here y is equal to cos of log x plus e raised to x. Okay. So then apply the derivative. So first of all, this is of the form cos of this whole function should be treated as a x. What is the derivative of cos x? Minus sin x. So first apply. Then dy by dx equal to derivative of this function should be cos of x. What is the derivative of cos x? Minus sin x. Minus sin of what is your x? X is log x plus e raised to x. So that this is a cos x form is there. So derivative of cos x is minus sin of x. Instead of x, what is there? This function. This is d by dx of log x plus e raised to x. So this is successive differentiation. Okay. Keep this function as it is. Minus sin of log x plus e raised to x. Then d by dx of log x is derivative of first function log x is 1 by x plus derivative of e raised to x is e raised to x. This is your final answer. Is clear that? So student, this is all about the exponential function as well as logarithmic function. So with by the rule, we apply by the rule of derivative of composition rule, more than 2 or more than 2 functions. So students, this is also 1 mark concept, very important for 1 mark concept. Is clear that? If people solve all the examples what I have given the work, and if you have any doubt, ask me. Okay? Thank you students.